Good day. So today I'm going to show you how to solve a question when we're given sine 3x is equals to 3 sine x minus 4 sine cubed x. So this question seems to bother a lot of students, so I have decided to create this video. So first of all, I'm going to tell you that you do have to memorize, you do have to cram your compound and double angles. A lot of people say don't cram them, they're in the formula sheet, but there are some disadvantages of not cramming them. If you don't cram them well, you won't be able to see them popping out. So usually in trigonometry, when it comes to proving identities, it's best to take the more complicated side and make it the same as the simple side. But in this case, because the simple side has got sine 3x, because it has got 3x, it's going to be best to take it and try and extend it. So we're obviously going to take the left hand side because it has got 3x, right? So then we're going to say sine 3x. So every time you've got sine 2x plus x, every time we've got 3x, so let's make it 2x plus x. Then we're going to expand it using compound angles. So with compound angles, whenever we've got sine, so if you have cos, for instance, if we have cos A plus B, we know it's going to be cos. So the first thing that you have to memorize is that cos is cos, cos, sine, sine. But sine is sine, cos, cos, sine. And then the other thing you have to memorize is that you use C for change. So meaning that if it's a plus, it's going to become a minus. And then you use S for same, meaning that if it's a plus, it stays plus, right? So S for same, meaning that the signs don't change, the sign stays the same. Then C for change, meaning that the signs will change. So remember, cos is cos, cos, sine, sine, and then sine is sine, cos, cos, sine. So using this, when we expand this, so this is going to be sine 2x sine x, or rather cos x, cos is sine, cos, cos, sine. And S for same, so the sign stays the same. So then it's going to be cos 2x sine x. Alright, then from here, you'll notice that this is a double angle. These two are double angles. So since this is a double angle, we're going to have to expand it. So when we expand it, sine 2x is 2 sine x cos x. And then cos 2x, there's 3 of them. So there are 3 of them. So we can choose any, but we have to choose the one that will benefit us. So if you notice, cos 2x is next to sine x. So it means the one that we choose must have sine x. So this one will be out. So we can choose either this one or this one. Either one will work. But I'm going to choose this one since it has got sine only. But either one that we choose will work. So I'm expanding cos 2x so that it can become 1 minus 2 sine squared x, because there is sine x next to it. Alright, so from here, when we multiply, it's going to become 2 sine x cos squared x. And then this is plus, so now we're going to have to distribute. So then this is going to be sine x minus 2 sine cubed x. Just before I continue, if you want to be tutored, either online or physically, online it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you want to be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvements. And then from here, when you look at this stuff, you realize that this is sine, this is sine, this is sine, but this one is cos. So in other words, it's not speaking the same language as the rest. So since it's not speaking the same language, we have to change it to speak the same language. So we have to make it speak the sine language. So then from there, this is going to be sine x, and then brackets, this is going to be 1 minus sine squared x. Then from there, this is going to be plus sine x minus 2 sine cubed x. So whenever something is not speaking the same language as the rest, you can never be stuck. You just have to change it to speak the same language as the rest. So then we're going to distribute. So when we distribute, this is going to be 2 sine x minus, then this is just like x times x squared, so this is going to be x cubed, so it's going to be sine cubed x. Then this is plus sine x minus 2 sine cubed x. Then from here you would notice like terms. The like terms are this and this and this and this. So if you notice, 2 sine x plus sine x is just like 2x plus x, which is 3x, so therefore it will become 3 sine x. And then also when you look at this stuff, minus 2 sine cubed minus 2 sine cubed is just like minus 2x, which is minus 4x. So therefore it will be minus 4 sine cubed x. And then we have it just the same as the right hand side. So then we can say equals to right hand side, and we're done. So if you like this video, please like and subscribe to my channel so that you can receive more videos like this. Good day. Today I'm going to show you how to deal with a question that says prove the identity when you're given that cos 3x is equals to cos x into 1 minus 4 sine x. So first of all, I'm going to tell you that you do have to memorize your compound and double angles. Some people say don't memorize it, it's in a formula sheet. There are advantages of memorizing this stuff. When you memorize this stuff, you'll be able to pick up when it is a double angle or a compound angle. So usually in trigonometry, when they say prove the identity, it's best to take the most complicated side and convert it to the simple side. But here in this case, since this one has got 3x, we're gonna have to take this side and make it complicated. So in this case, I'm gonna choose my left hand side. So I choose the left hand side. So then for the left hand side, every time you've got cos 3x, you have to take it and make it cos 2x plus x. So then we're going to say cos 2x plus x. And then from here, we're going to expand it using compound angles. So the purpose that we split it like that was so that we can expand it using compound angles. So using compound angles, we know that cos is cos, cos, sine, sine, while sine is sine, cos, cos, sine, right? So therefore this will be cos 2x, cos x, and c for change. So when you see c, it means it's gonna change. So then therefore it's gonna be sine 2x sine x. Then from here, you would notice that this is double angle. This and this. These are double angles, right? So then we're going to expand it using double angles. So with cos, there is 3 of them. So cos has 3 of them. There's cos squared x minus sine squared x, and we've got 2 cos squared x minus 1, and we've got 1 minus 2 sine squared x. So you can choose any 3, but in order to just use a method that is efficient, the method that best benefits you, notice that here we have got cos next to it. So because we have got cos next to the one that we want to expand, it's best to expand it to the one that is cos. So in other words, this one is out. So we can either use this one or this one, but the best option is this one because it has got cos only, right? This one is cos that is next to it, so it's best to take this one because it's cos only. So we're going to expand that, so let's expand it. So we choose 2 cos squared x minus 1 due to the fact that it was cos that was next to it. So, and then from this side, sine has only one of them, so which is 2 sine x cos x. And then we've got sine x. All right, then from here we're gonna distribute. So let's distribute. So when we distribute, it's gonna become 2 cos cubed x minus cos x. And then this side, when we just multiply, we don't have to distribute because there's no plus, it's a multiplication sign. So then this side is just gonna be 2 sine squared x cos x It's just like xy times x. Xy times x, if we had xy times x, it will just be x squared y. So that's what's going on here. And guess what? If you notice, this is cos, sine, cos. So all of them are speaking the cos language, but this one is not speaking the same language as the other ones. So it means we have to change this so that it can speak the same language as the rest. So then this one is just cos cubed. It will remain the same, minus cos x minus 2. Then we have to expand this. This is going to be 1 minus cos squared x. And this is cos x. Then from there, we're going to have to distribute. So therefore, this is going to be 2 cos cubed x. So we have 2 cos cubed x minus cos x minus 2 when we distribute plus 2 cos. Alright, so now we have to distribute. But now my advice is, you see, notice we've got 3 things multiplying, right? We've got this multiplied by this bracket multiplied by this. Whenever I've got 3 things multiplying, my advice is to deal with the last 2 first before the first one. So let's deal with the last 2. So then this is going to be 2 cos cubed x minus cos x minus 2. So we're not yet going to multiply the 2. We're going to rather multiply this stuff. So then this is going to be cos x, and then this is going to be cos cubed x. And that's what we have. So then from there, I'm going to write this on the next step. All right, so I just rewrote the previous step here. Okay, then from here, now we're going to have to distribute that. So in the previous step, we just multiplied, and then we left out the 2. So now this time we're going to distribute the 2. So then we have cos cubed x minus cos x minus, so then we're going to distribute that. So that is going to become 2 cos x. Then this is going to become plus. Negative times negative is positive. So then it's going to be 2 cos cubed x. And then from there, we look for like terms. So notice this and this are like terms. So we've got cos cubed x and cos cubed x. So then this is going to be 4 cos cubed x. So then we're going to have 4 cos cubed x. And then this side, we have like terms also. So then this is going to be, so this is like minus x minus 2x. Minus x minus 2x is minus 3x. So therefore, it's going to be minus 3 cos x. Right, so it's going to be minus 3 cos x. And then from here, we're not yet where the answer is. So what do? Notice we... Alright, so I have rewritten the previous step here with nothing changed. Alright, so in order for us to get this, we just multiplied the last 2. So now we're going to have to distribute this one. So this is 2 cos cubed x minus cos x. Then we have to distribute the one. So then this is going to be minus 2 cos x. And then this becomes plus 2 cos cubed x. And then, of course, we have to look for like terms. So let's look for like terms. So then you would notice that this and this are like terms, right? Cos cubed, and I've got 2 plus 2, so hence this is going to be 4 cos cubed x. So this is 4 cos cubed x, and then now this one we have got minus cos x minus 2 cos x. So this is the same as minus x minus 2x. So then minus x minus 2x is minus 3x. Therefore, minus cos minus 2 cos is minus 3 cos x. So far, we're almost at the answer. So now I see a sign there. So I see sign. So it means we're going to have to change something. But now instead of changing, I see something. I see that this is cos and cos. So I can factorize. Besides, look at this. It means it was factorized. So if this is factorized, it means that it's going to be cos x. So let's factorize cos, because cos appears here and here. That's another skill you need. When you see cos here and here, we need to factorize. So this in the bracket is going to be 4 cos squared x minus 3 So then I'm going to have to change this into sine so that it can be the same as that. In matter of fact, I realized that this is actually squared. This was supposed to be a question. The question has it as squared. Okay, so then this side I have to change it. So let's change that. Then this becomes 4. Then this, so I have to change this so that I can make it the same as that. So this is going to be 1 minus sine squared minus 3. And then this side, when we distribute, this is going to be cos x. Then this is going to be 4 minus 4 sine squared minus 3. So remember, whenever we expand one thing to become 2 or more, we have to put it in brackets so that we can distribute. So now we have this. Let me just rewrite this. Okay, so I rewrote this with nothing changed. Okay, then this, you will notice that these are like terms. So 4 minus 3 is 1. So therefore we can say it's cos x. Then we have 1 minus 4 sine squared. Or rather, yep, sine. This is sine squared. Alright, I rewrote this with nothing changed. So then you realize that these are like terms. So 4 minus 3 is 1. So therefore we'll have cos x. And we'll have 1 minus 4 sine squared x, which is exactly the same as the right hand side. So it's the same as the right hand side. So therefore we can say equals to right hand side. Alright, so if you enjoyed this video, don't forget to like and subscribe to my video so that so if you like this video, please like and subscribe to my channel so that you can receive more videos like this.